All right, in section 3.2, number 61, we're looking at this piecewise function to graph. So let's start with this one, and we'll put this one in green. So first I'm going to look at the y-intercept, which is 5. So I know it's going to, let's see, that's pretty high on this graph. So I'm going to label this graph by 2's because they're also going to be at the top of the graph and not have much space. And let's see, I think we can keep these by 1. Let's try that. Okay, so my green graph is going to have a y-intercept of 5. So b equals 5. So it'll intercept right here. And I'm also going to look at this boundary because I know there's going to be an open circle or hole at x equals 2. So if I plug in 2 there, I get 5 minus 2. If I plug in 2 for x, I get that y is 5 minus 4, or 1. So I know there's a hole when x is 2 and y is 1. So I'll go to x2, y1. So I know there's a hole right here. So I know these two points are on this line, the 2, 1 and the 0, 5. So if I were to draw this whole line, I could connect these 2 points with a straight line and just go in both directions. And that's the whole line. But I see I'm restricted to the x is less than 2. So that means this line actually only goes up to that open circle that's at x equal 2. It goes forever in the other direction, so I'll go ahead and put an arrow there. Okay, now what about the other line? Let's do the other line in purple. So if I have 3x minus 2, my y-intercept there is a negative 2. So my purple graph, my purple function, the y-intercept is negative 2. So that's down here. Oh, wait, I'm sorry, it's not because my graph here is scaled by 2's. There we go. And I'm also going to plug in that 2 because there's going to be a hole there. So when x equals 2, I get 3 times 2 minus 2. Then y equals 6 minus 2, which is 4. So I know that that purple graph will contain the point 2, 4. So I go to, let me make sure that's right, 2, 6 minus 2, yeah, okay. So I go to 2, 4, and I know there's an open hole, there's a hole there because it's never equal, right? It's strictly greater than. So there's going to be a hole there. And then if I were to just draw that straight line without the domain restriction, then it looks like that straight line that connects those 2 points. And it goes on from there. But my domain is restricted to x greater than 2. So that means this line actually is going to get smushed down to start at 2 with the hole at 2. So there's actually no point right there. Okay, so that's my piecewise function. And then my next questions are, state the domain and the range. So the domain's going to be, the green function goes all the way left for infinity. So it will start at infinity, negative infinity, sorry. And my purple one, goes forever to the right. So it goes to infinity, but there's a hole at 2 and it never gets filled. Both of these functions have it a strictly less than, strictly greater than, never equal signs. So that means my domain's going to have to exclude the number 2. So it starts from negative infinity, goes to 2, and then starts again right after 2 and goes up to infinity. So that's my domain. And then my range That's the y value. So that starts right here at y equals 1, but doesn't include 1 because it's an open circle. And all values from 1 be up above 1 have some value. Even at this hole, you can see there's a y value over here. So it goes on for infinity. And then we have, where is it increasing? Let's do, it's increasing. The purple segment is increasing, so that domain is x greater than 2, or starting at 2 but not including 2 and going to infinity. And the decreasing is everything on the green line. So that's like when you're walking along the green line, you're walking downhill, so that means it's decreasing. So that's a negative infinity all the way up to that open hole at 2. Right, this is the decreasing line. And a constant, there's no constant. There's no horizontal line, so there's no constant. All right, so that looks like everything.